Hi all, welcome to Edumonk. Today we are starting with our UPSC Geography syllabus. UPSC Geography syllabus. Actually, the Geography syllabus it's divided into two parts: World Geography and Indian Geography. Initial stage we are going with discussion about basics of geography. Basics of geography. Then we'll move to World Geography and Indian Geography. Okay, then we can divide the basic of geography into different parts. In first session we are discussing about our solar system. Our solar system we will discuss about what is our universe, stars, constellations, comets, different planets, theories behind our solar system, and previous year questions. Then we will move with our formation of Earth. Initial stage we will discuss about what is Earth, how it is formed, then interior of our Earth. Then we will move with our ancient physical features of our Earth, that is land and ocean. Then we will move to physical features of Earth, both in land and ocean. It will cover with our mountains, then drainage system, that's rivers, then plateaus, etc. Then we will move with our climate or climatology. In climatology we will discuss about what are the different climate in the world, what are the factors controls our climate, then a simple trick to identify climate anywhere in the world. Okay, then we can move to the next part, our drainage system. Drainage system means our river systems. Here we have to study both the world drainage system and Indian drainage system. We have to look after the Indian drainage system specifically. Then we will move on to biogeography and human geography. Okay, then we can start with our first topic, that is our solar system. First of all, we have to understand what is our universe. what is our universe. Okay, universe means universe encompasses everything that exists. The vast galact the vast galactic mega clusters to that tiniest subatomic particles. Sim- simply universe simply we can say that universe is the place where everything that exists everything that exists the place where everything that exists, that's known as our universe. It's from our vast galactic mega clusters to the tiniest subatomic particles. This is known as universe. The age of our universe. This is one of the major doubtful question. Most of the scientists agree that it's bound around 17.39 billion years old. This year is just an assumption. Our universe is 13.79 billion years old. This universe consists of different galaxies. The universe consists of different galaxies. Different galaxies. Then what is these galaxies? We can look into that galaxy. Galaxy is the massive collection of stars, planets, and other celestial bodies held together by its gravitational forces. Okay, here you have to understand there is a gravitational force. These force making stars, planet, and other celestial bodies to held together. To held together. This combination of star, planet, celestial bodies, and other particles in the space is known as galaxies. Most of the galaxies are in spiral shape. Most of the galaxies are in spiral shape. Okay. Then the galaxy which our solar system exists is known as Milky Way. In Milky Way galaxy, our solar system exists. This Milky Way galaxy, otherwise known as Akash Ganga. Akash Ganga. Akash Ganga. This Milky Way or Akash Ganga galaxy also in spiral shape. Spiral shape. Then nearest to Milky Way galaxy, there is another galaxy is present there. It's known as Andromeda. Andromeda galaxy. Andromeda galaxy. This is also spiral shaped galaxy. Spiral shaped galaxy. In a galaxy, there are stars, planets, and celestial bodies. First of all, we can look into stars. Then, what are stars? These stars are luminous celestial bodies that emit their own light, and other forms of radiant energy. This is known as stars. Then how they emit their lights? That's a question. Here the stars are the luminous celestial bodies that emit their own light and their forms of and other forms of radiant energies. Then how they emit their light? These stars are made up of or made of extremely hot burning gases. These stars are extremely made up of extremely hot burning gases. Here the hot burning gas is hydrogen. Hot burning gas is hydrogen. Here the hydrogen atoms smash together. The hydrogen atoms smash together and which forms to helium plus energy. This energy is our light. This process is called as nuclear fusion. So stars emits their light energy through nuclear fusion by smashing together of small atoms to large atom. As a part of the process, as a part of the nuclear fusion, their energy is released, which we are see as a uh, which we saw as the light energy of stars. There are different kinds of star in different color. If you see a star in a red color, if you see a star in a red color, if you see a star in a red color, that's in low temperature star. Low temperature star. If you see a star in a color, yellow color, that's a medium temperature star. If you see a star in a blue color, these are very high temperature stars. These are very high temperature stars. These stars are cosmic energy engines. These are stars are cosmic energy engines. This produces heat, light, ultraviolet rays, X-rays, and also other forms of radiation. Other forms of radiation. These are composed of largely gas and plasma. What is plasma? Most of you will know that plasma is a fourth stage of matter. Otherwise, it can be said as it's a superheated state of matter. Superheated state of matter. Okay. Then these stars are the fundamental building block of our galaxies. Fundamental building blocks of our galaxies. Then we can move into the birth to death or life of a star. By going to life of star, every star's birth is from just this stellar nebula. This stellar nebula is a cloud of dust and gas. It's a cloud of dust and gas. Every star bursts from stellar nebula. It's a cloud of dust and gas. Then this stellar nebula can be converted into, it can be an average star, it can be a massive star. Then we already discussed about how light is formed from a star. It's due to uh, the conversion of hydrogen into helium as the part of nuclear fusion. When the hydrogen gas in these stars fused and forms helium, then these stars come to an exist. When the hydrogen nuclear fusion starts, this stars comes to an existence, so it became an average star or massive star. After that, this is otherwise known as the protostar. This is otherwise known as the protostar. Then after that, the complete hydrogen used up and helium started to fuse with carbon. The uh, life of star stops. The average star converted to a red giant, then planetary nebula and white dwarf. White dwarf is the dead star. But these will also emit light by radiating the stored heat. These white dwarf converted to black dwarf. This white dwarf converted to black dwarf by cooling. The same kind, the massive star after the complete nuclear fusion, which converts to red supergiant, then to supernova and black hole. These are the complete lifespan or life cycle of a star. Then our nearest star to Earth is Sun. Then it's followed by Proxima, then Alpha Centauri. These are the three stars which is near to our Earth. Then we can go to other next topic, constellations. Constellations. Thousands of stars appear in the night sky during the night. Some of these stars form a pattern in group which have a recognizable shape. This group of stars is called as constellations. At present, there are 88 constellations. Each constellation has been given a name according to its shape. Some of the important constellations are Ursa Major, Ursa Minor, Orion, Leo Major, and Cassiopeia. You may these are mainly used for historical time date or our old age time period, these are mainly used for navigation purpose. By through the stars are uh, stars most of the cases stars appear in a fixed position at the nights in specific times and year. By using this, most of the ships are navigated to their destinations. Some of the examples are Ursa, Ursa Major. This is known as Great Bear. This is known as Great Bear or Saptarshi. Saptarshi. Then Orion. This is known as Hunter. Then Leo Major. Then Cassiopeia. Cassiopeia. These are the major constellations. By total, 88 constellations are present there. These constellations are the group of stars forming a recognizable pattern in the night sky. Most of these constellations are used for navigation purpose. Okay, then we can move to our next topic, star sun. Initially, we discussed about our universe, then galaxies. Our galaxy is Milky Way, then star. In Milky Way galaxy, our star is Sun. Then we are discussing about our star of our Milky Way galaxy, our solar system, Sun. Initial, we can just an overview of our Sun. Its diameter is just 1.4 million kilometer. Then mass is about 1.989 into 10 raised 30 kilograms. Then distance from Earth 149.6 million kilometers. Surface temperature is 5,500 degrees Celsius. Star type, it's a G type main sequence star. Then its composition we can look later. Then we can move to the Sun. Our star Sun, it consists of extremely hot gases, particularly bulk hydrogen. Around 70%. Then helium 26.5%, and other gas is 3.5%. The hydrogen is the main fuel for the nuclear fusion. That's why our star emit its lights. When the hydrogen fuel or when the hydrogen fuel drains up, the star will be dead. This star or the sun is 109 times bigger than our Earth, and it accounts for 99.83% of our solar system. The sun only consists of 99.83% of our solar system. Then the sunlight takes 8 minutes to reach Earth's surface. Then most of you may have a doubt that how the planets revolves around the sun in a fixed path. You may have seen the figure of solar system. There should be the sun, then first planet rotates here, next planet rotates here, and next planet rotates here. How they are using a fixed path? The answer is gravitational force. Sun has a massive gravitational force. So the sun controls the planets, other celestial bodies, other satellites in a fixed path. It should be in a elliptical shape. In this core, we already said about nuclear fusion. In the core, hydrogen fuses together and forms helium. This is known as nuclear fusion, which emits light energy. Then we can move into another part, rotation of our sun. Then rotation of sun. Our planet Earth has rotation and revolution. Earth rotates on its imaginary axis. Its takes on complete rotation is just 24 hours. That means 1 day. In same kind, sun is also rotating. Also rotating in imaginary axis. But there is a difference. The sun has different layers. Sun has different layers. So each layers rotates in different time. The average time taken for sun for one rotation is 24 days. Average time for one rotation is 24 days. Why this average time? The inner part, sorry, it's not 24 days, it's 27 days. Average time taken for sun's on rotation is 27 days. Its equator spins at equator completes one rotation in 27 days. Sorry, equator takes 24 days for its rotation. Then the poles takes 30 days for its rotation. For average, 27 days is the one. It's a time taken for sun's one rotation. This is the rotation of sun. The average time taken for it 27 days. Equator complete one rotation in 24 days, and pole takes one rotation in 30 days. Then we can move the nuclear fusion inside the sun. The nuclear fusion inside the sun, which produce huge amount of energy, huge amount of energy. This radiated outwards to the surface, sun's atmosphere, and its beyond. Then we have to understand what is surface and atmosphere of sun. So we have to understand about the sun's internal structure and atmosphere. Internal structure and atmosphere. The sun's layers are different from each other, and each plays a part in producing the energy that sun ultimately emits. In solar interior, from the inside out, it is made up of core. It's made up of core, radiative zone, and convection zone. Inside the core, nuclear energy release, the core is approximately 20 percentage of the size of solar interior. 20% size of solar interior, and it's have a temperature of approximately 50 million Kelvin. That's the temperature inside core of sun. 50 million Kelvin, which is the hottest part of our sun. Its core, hottest part of our sun. Then above the core, you can see a region called a radiative zone. Radiative zone. This is the primary mode of transportation of energy across it. This region starts at about 25% of distance to solar surface and extends up to about 70% of the way to the surface. That means 20% core. After that, 25 to 70%. That most of the percentage is the part of radiative zones of interior of sun. The light generated in the core is transported through the radiative zone very slowly. The high density of matter in this region means a photon cannot travel too far without encountering the particle, causing it to change direction to lose some energy. The convection zone, it's an outer or outermost layer of the solar interior. It is a thick layer approximately 2 lakh kilometers deep. 2 lakh kilometers deep, which transport energy from the edge of radiative zones to surface through giant convection cell. Similar to the pot of boiled out milk, the plasma at the bottom of the convective zone is extremely hot and it bubbles to the surface where it loses its heat to space. Once the plasma cools, it sinks back to the bottom to convective zone. Here we have to understand some parts of the sun. Initial, we have to understand what is photosphere, solar photosphere. It is the lowest layer of our solar atmosphere. Lowest layer of solar atmosphere. And also its visible surface of the sun. Visible surface of our sun. Then the next specialty of photosphere is it is bright outer layer of the sun which emits most of the radiation from the earth. Also the photosphere is an extremely uneven surface. Extremely uneven surface. Extremely uneven surface. The effective temperature or average temperature in photosphere is around 6000 degrees Celsius. The outermost atmosphere of sun is around 6000 degrees Celsius. Next, we have to understand about the chromosphere. Chromosphere. It's a second of three of the main layers in the sun's atmosphere and roughly 3000 to 5 kilometers deep. It is in the 3000 to 5 kilometers deep. This is the thin layer of burned glass. Thin layer of burned gas. It's a thin layer of burned gas. Temperature is just 10,000 Kelvin. 10,000 Kelvin. Then we have to look into corona. It is the outermost part of sun's atmosphere. Outermost part of sun's atmosphere. It's called as corona. This corona is mostly visible in the time of total eclipse. Total eclipse. This time it's highly visible from our Earth. This corona extends from millions of kilometers into space and most of easily seen during the total solar eclipse. Okay, these are the major part of our sun, that is photosphere, then chromosphere and corona. Then we can move to some phenomena by our sun or solar system. Then we can move into some phenomena by our solar system. First one is solar wind. Solar wind. Solar wind is the wind of some energized or charged particle. Solar wind is the stream of some energized or charged particles. These charged particles can be electrons. Charged particles can be electrons or protons. These flowing outward from the sun at the speed of 900 kilometers per second and temperature of 1 million degree. This is known as solar wind. Solar wind is a stream of energized and charged particles. These energized or charged particles are electrons and protons. They emit or flowing outward from the sun at a speed of 900 kilometer per second at the temperature of 1 million degree. This solar wind completely made up of plasma or ionized particles. Ionized particles. Then, what are the effects of this solar wind? Due to the solar wind, you may see about aurora. Aurora. This is the natural light display in the sky. Natural light display in the sky. It is most predominantly seen in the high latitude region, mostly in Arctic and Antarctic region. This is due to the magnetic fields of Earth and solar wind. These are caused by charged particles. These aurora lights are formed due to charged particles through the solar wind. Then we have to look into the second phenomenon, solar prominence. Solar prominence. Solar prominence means it's an arc of gas which is erupted from the surface of sun, These prominence can be looped into hundreds of thousands of miles into space. These prominence are held above the sun's surface by strong magnetic field, can last for many months. At some time their existence, most prominence will erupt, sweeping enormous amounts of solar material into space. Then we can move into the next thing is plasma. Plasma is the one of the four fundamental states of matter, two other being solid, liquid and gas. After the fourth one is plasma. Plasma means it's an ionized gas. Ionized gas. That means atoms and molecules are converted into ions, typically by removing one or more electron from its outer shell. That's known as ionized gas. You may most of the time you may saw about the lightning and electric sparks. These are made up by the plasma. Or ionized particles. If you want to know more about the plasma or plasma lights, you may know about neon lights. It can be called as our plasma lights. These are ionized particles. In neon lights, the light comes from the plasma inside of them. That's known as neon lights. Then we can move into another phenomenon, sunspots. These sunspots are areas that appear dark on the surface of sun. These are the areas which seen as dark on surface of sun, which is known as sunspot. These are seen mostly in photosphere. Then why they are in a dark colored? The answer is these areas are normally cooler than other part. That means sunspot is cooler other other parts of sun are hotter, so that these areas are seen in a or appear in a dark on the surface of sun. Normally, the average temperature of this kind of sunspot is around 600 sorry 6500 degree Fahrenheit. Fahrenheit. And also, photosphere is a visible surface of our sun, as we told earlier, from which is emitted most of the sun's light and reaches us Earth directly. There are relatively These sunspots are relatively cool because it's formed at the areas where magnetic fields are particularly strong. First point of sunspot is these are cooler area than other area. Second thing is this forms at the areas where magnetic fields are particularly strong. First point is these are cooler part. Second point is these are formed in the region where magnetic fields are particularly strong. That means the magnetic fields of this area is 2500 times more than the magnetic fields in Earth. Magnetic fields in the Earth. The sunspot, which are seen in two kind of circle, or which are seen in two layers, one inside layer and outside layer. Inside layer and outside layer. The inside layer, it is mostly in darker, and outside layer is lighter. This dark region or inner layer, which is known as umbra, the less darker region or lighter region or outer layer, which is known as penumbra. 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 The inside layer is known as umbra and outer layer is known as penumbra. Okay. In next one is these sunspots are directly related with solar cycle. These sunspots are directly related with solar cycle that we can discuss further. Then we can move with our solar cycle. As we know, sun is a huge ball of electricity charged hot gas. This charged gas moves, generating a powerful magnetic field. This sun magnetic field goes through a cycle which is known as solar cycle. The time scale of solar scale is 11 years. In each 11 years, sun's magnetic field completely flips. This means that sun's north and south poles take places. If you know, this is sun. This is a energized hot gas ball. So there is a north pole and south pole. In each 11 years, its poles will switches. North pole will go to south and south pole will go to north. This is known as solar cycle, which will repeat in every 11 years. This solar cycle affects activity on the surface of the sun, such as a sunspot. As we said earlier, sunspot. These are caused by the magnetic field of sun. As the magnetic field changes, the amount of activity on the sun surface changes. One way to track our solar cycle is by counting the number of sunspots. There should be, you understand, the solar minimum and solar maximum. Solar minimum is where beginning of solar cycle, where the sunspot are less. Solar maximum is the middle of solar cycle, where sunspots are high. When the solar cycle ends, there should be solar minimum, so that sunspots are less. From the number of solar sunspots, we can find what is the current position of the solar cycle. Then we can move to our solar system. In our solar system, there is a star, planet, and other bodies. This star, in our solar system, our star is sun. Sun exerts a gravity. So that the gravitational pull of sun, the planet and other bodies are held together in a particular path. That's known as our solar system. Our major planets are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Then we have our dwarf planet Pluto. Pluto. These are our planet. This is our star sun. Then Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Then Pluto, it's a dwarf planet. It can't be considered as planet. In addition to that, there should be dozens of moons, then millions of asteroids, and comets, also meteoroids. Millions of. This is actually our solar system. Solar system consists of sun, then planets, its satellites or moons, asteroids, comets, then meteoroids, etc. These are known as our solar system. Then we already discussed about star or sun of our solar system. Then we can move to each planet. These planets are wanderers. There are 8 planets in our solar system. That's Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. All these planets move around the sun in a fixed orbit. That is elliptical or elongated shape. Now also that the International Astronomical Union recognized 5 dwarf planets such as Ceres. 5 dwarf planets are, first one is Ceres, second one is Pluto, third one is Haumea, fourth one is Makemake, and fifth one is Sedan. Fifth one is Sedan. Then our planets are grouped into two categories. First one is terrestrial planet and second one is gas giants or Jovian planet. Jovian planet. These terrestrial planets are dense rocky bodies. Dense rocky bodies. Dense rocky bodies or earth-like structure. Earth-like structure. But the Jovian planets, these are in gigantic size and these are gaseous in composition. Gigantic and gaseous. These gas giants also have large satellites. Then these terrestrial planets, Mercury, Venus, Earth and Mars. These are terrestrial planets. Then gas giants are other four ones are Jupiter, Saturn, Uranus and Neptune. These are gas giants or gigantic or Jovian kind of planets or gas giants. These are inner planets. Then other four are outer planets. In the inner planet, we can see a similar kind of feature. These sizes are very small, nearly the size of the Earth. In the terrestrial it's a gas giants, you can see these are huge kind of planets. In the inner planet, there are nitrogen and carbon dioxide are present in the atmosphere. In the gas giants, there are mostly different kinds of gases, so it's called as gas giants. Then we can move to next topic. We have to understand one more topic here or one more concept, that is Kuiper belt. Kuiper belt, that means this is the region of the solar system that exists beyond the 8 major planets. This is the region of solar system exists beyond 8 major planets. That's known as Kuiper belt. That means the area of the solar system that exists beyond, not inner 8 planets, it's existed beyond the 8 planets. That's known as Kuiper belt. Then we can go to first planet, Mercury. The diameter of Mercury is 4,880 kilometers. Then mass is 3 into 3 into 10 raised to 23 kilograms. Distance is 57.9 million kilometers. Distance to Sun. Length of the day is 59 Earth days. Length of a day, 59 Earth days. Length of an year is 88 Earth days. Length of an year means the planets which takes times to revolution or complete a revolution around Sun. That's known as length of the year. That's the Mercury takes 88 days for one revolution. Then surface temperature is minus 173 degree to 427 degrees Celsius. Then composition, Mercury has a thin almost non-existent atmosphere, mostly composed of trace amounts of helium, hydrogen, and oxygen. Then Mercury is the smallest planet in our solar system. Smallest planet in solar system. Mercury is the smallest planet in our solar system. Then it is the closest planet, smallest planet, then closest planet. Then one day in Mercury takes 59 days, we already then Mercury is the terrestrial planet. That means a rocky planet. Then it's also known as terrestrial planet. It has a thin atmosphere or exosphere. It is composed in most of oxygen, composed of oxygen, sodium, hydrogen, helium, then potassium. These are the major things or composition in Mercury. There are 2 missions have visited the rocky planet. First mission is Mariner 10 in 1974 and 75. Then Messenger, 2 missions which have visited the rocky planet Mercury. Mariner 10 in 1974 to 75 and Messenger. Then Mercury 3 times before going to orbit around Mercury in 2011. The daytime temperature, daytime temperature in Mercury, which can be reached to 430 degrees Celsius, and night, which can drop up to minus 190 degrees Celsius. In daytime, which can be reach up to 430 degrees Celsius, and night time, which can be reach or drop up to minus 190 degree Celsius. Then we will move to next planet, Venus. Venus, as an overview, its diameter is 12,104 kilometers. Its mass is around 4.87 into 10 raised to 24 kilograms. Distance from Sun is 108.2 million kilometers. Length of the day around 243 Earth days. Length of the year is 225 Earth days. Surface temperature is 467 degrees Celsius. Then composition, it has a thick atmosphere. The Mercury had a thin atmosphere. Here Venus has a thick atmosphere, mainly consists of carbon dioxide 96.5%, which traces of nitrogen and other gas. Venus is just smaller than Earth. Then it's a terrestrial or a rocky planet. Then around 40 spacecraft visited Venus. Around 40 spacecraft visited Venus yet. It has extremely high temperature around 480 degrees Celsius. Temperature up to 480 degrees Celsius in this Venus. Then the Venus spin backward. most of the planets like Earth, sun rise in the east. Sunrise east, uh, sets in the sunset in the west in most of the planet like Earth, but in Venus sunrise in west, sunset in east. That's why the Venus spins backward. Then we can move to our next planet, Earth. As an overview, you can see it has a diameter of 12,742 kilometers. Mass is 5.97 into 10 raised to 24 kilograms. Distance from Sun is 149.6 million kilometers. Length of the day is 24 hours. Length of the year is 365.24 days. Length of the year is 365 into 24 days. Then also composition is 32.1% of iron, 30.1% of oxygen, 15.1% of silicon, 13.9% of magnesium, and 2.9% of sulfur and other elements. Earth is the third planet from the Sun, which had distance about 150 million kilometers that already we discussed. Earth atmosphere consists of around nitrogen around 78.78 percentage, then oxygen around 21 percentage, and other things around 1 percentage. Earth has one moon. Another name of this moon is natural satellite. Earth is the perfect place for life. As we know, our atmosphere protects us from incoming meteoroids and other breakup in atmosphere and meteoroids. We can discuss about the Earth and its physical feature later. We can go to our next planet, Mars. As discussed, then the diameter of Mars is 6779 kilometers. Then mass is around 0.64171 into 10 raised to 24 kilograms. Distance from Sun is 225 million kilometers. Length of the day is 24 hours and 39 minutes. Length of the year is 687 Earth days. Surface temperature is -5 degrees Celsius to -87 degrees Celsius. Mars also has a thin atmosphere composed of mainly on carbon dioxide, around 95.3% with traces of nitrogen and argon. Here, then Mars is a fourth planet from the Sun, distance around 228 million kilometers. That's already we discussed. Then Mars takes just a little over 24 hours to complete one rotation. Then Mars is a rocky planet or terrestrial planet. It has a solid surface. Which has been altered by volcanoes, crustal movements. So that volcanoes are present in the Mars. Also, there are dust storms are present. Then Mars has a thin atmosphere, carbon dioxide, nitrogen, and argon. Mars has two moons or natural. Mars has two moons, natural satellites, which is known as Phobos, Deimos. These are the two natural satellites of Mars. Many or several missions have visited the planet, from flybys and orbiters to rovers on the surface of Red Planet. The first true Mars mission success was Mariner 4 in 1965. Mariner 4 9065. At this time, the planet history Mars surface cannot support life as we know, but current mission exploring Mars on the surface and from the orbit are determining Mars past and future potential for life. Also, Mars is known as a red planet because presence of iron minerals. How these iron minerals are present in the red planet? It's due to the volcanism. That we can discuss later in the volcanoes in our Earth structure. We can understand how the iron kind of materials are comes out from the volcanoes. Then we can go to the next planet, Jupiter. Then the diameter of Jupiter is 139,822 kilometers. Then mass is 1.898 into 10 raised to 27 kilograms. Distance from Sun is 778 million kilometers. Distance from Earth is 365 million kilometers. Length of the day is 9 Earth hours. Length of the year is 11.86 Earth years. Composition, it is primarily composed of hydrogen and helium, making a gas giant. It lacks solid surface and consists of many thick layers of gas. Then we can move to further. Here you can see as per the size of Jupiter, around 1300 Earth fits inside the Jupiter. Fits inside the Jupiter. Jupiter is the fifth planet from the Sun. Same kind, it's a gas giant. Jupiter's atmosphere is made up of hydrogen and helium. Jupiter has 50 moons. Why is 50 moons? With additional 17 moons awaiting for confirmation. 17 moons awaiting for confirmation. If 17 moons are accepted, the Jupiter should have 67 moons. 67 moons. Many of the missions are visited Jupiter and its system of moons. The Juno mission will arrive at Jupiter in 2016. Jupiter cannot support life as we know. However, some Jupiter's moons have oceans underneath their crust and might support life. Then we can move to Saturn, the planet Saturn. Planet Saturn, its diameter is around 116,464 kilometers. Then mass is around 5.68 into 10 raised to 26 kilometers. Distance is around 1.42 billion kilometers. Distance from the Earth is 365 million kilometers. Length of one day is 10 hours and 33 minutes. Length of an year is 30 Earth years. Then composition, it is primarily composed of hydrogen, helium and other gaseous compounds. Then we can move to the another part. Here we know Saturn is a gas giant planet and does not have the solid surface. It's a sixth planet from the Sun. Then Saturn has 53 moons. Saturn has 53 moons. Then additional 9 moons are awaiting for the confirmation. If the 9 moons get confirmation, it should have 62 moons. Total 62 moons. Only few missions have visited the Saturn: Pioneer 11 mission, Voyager 1 and 2 mission, Cassini-Huygens since 2004. Then we can move to these are the smaller facts about the Saturn. We can move to the next planet, the planet Uranus. Uranus, its diameter is 51,118 kilometers. Mass is about 8.68 raised 10 raised to 25 kilograms. Distance from Sun is 2.87 billion kilometers. Distance from Earth is 2.7 billion kilometers. Length of the day is 17 hours and 14 minutes. Length of the year is 84 days. Then Uranus is the seventh planet from the Sun at a distance about 2.9 billion kilometers. Then Uranus is an ice giant. Ice giant. It's a gaseous planet or Jovian planet. Uh, it's because this planet is known as ice giant because of it's 80% of area, so composition or planet is made up of icy material that can be water, methane, and ammonia. So it's known as icy giant. This gas giant is made by a thin solid core. On above that, the icy structure is there. So it's called as a Jovian or a gaseous planet. Uranus has total 27 moons. 27 moons. Then also Uranus has 13 rings. Uranus has 27 moons and 13 rings. Voyager 2 is the one of the spacecraft which have visited Uranus. Voyager 2 is the only spacecraft visited Uranus. Uranus cannot support life as we know it. Then we can move to the eighth and last planet, Neptune. Diameter of Neptune is 49.244 kilometers. Mass is around 1.024 into 10 raised to 26 kilograms. Distance from Sun is 4.5 billion kilometers. Distance from Earth is 4.3 billion kilometers. Length of the day is 16 hours and 6 minutes. Earth years. Then we can move more on this. Neptune has 13 moons. Neptune has 6 rings around it. Neptune has 13 moons and 6 rings around it. Then Neptune's atmosphere is mostly made up of hydrogen. Atmosphere in Neptune made up of hydrogen, helium, and methane. These are the basic details about planet in our solar system. Then we can move with the other objects like moon, asteroids, meteoroids, and comets. Then we can discuss about moon, which is Earth's natural satellite. Earth natural satellite. Okay, this satellite orbits the Earth at a distance of 384,000 kilometer. 384,000 kilometer, which is orbits around our Earth, which take 27.32 Earth days for one complete revolution around Earth. Complete revolution around Earth. In same kind, rotates Earth on its own imaginary axis. Imaginary axis. Then surface of moon. Surface of moon. It is a rocky structure. Solid surface body. Solid surface body. Then moon has very weak atmosphere. Weak atmosphere. Then around 100 spacecraft has been launched to explore the moon. It is the only celestial body beyond Earth that has been visited by human beings. You know about that. 12 human beings were walked on the surface of moon yet. Then we have to look into what is asteroid. What is asteroids? Then asteroids. Asteroids are minor planets. These are minor planets which is inside solar system. Asteroids are minor planet which is inside our solar system. This is known as asteroids. These asteroids orbit our sun in a region of space between orbits of Mars and Jupiter. Mars, Jupiter. In between the Mars and Jupiter, asteroids orbits around the sun. Asteroids orbits around the sun. This is known as, this space between Mars and Jupiter is known as asteroid belt. In between Mars and Jupiter, asteroid orbits around the sun, which is known as the area between Mars and Jupiter, which is known as asteroid belt. Then these asteroids are rocky, solid and irregular bodies. This doesn't have atmosphere. This does not have atmosphere. More than 150 asteroids are known to have small companion of moon. The first discovery of an asteroid moon system was of asteroid Ida. Its moon dated in 1993. Then asteroids do not have rings. Asteroid do not have rings, and asteroid doesn't support life. Asteroids doesn't support life. Then we can move into meteors and meteorites. We have discussed about asteroids. These asteroids sometimes smash with each other and break up into minor parts or remains. These minor parts are known as meteoroids. These minor parts are known as meteoroids. Asteroids sometimes smash with each other and break up into minor remains. These minor parts are known as meteoroids, which orbits around sun. Orbit around sun. We know asteroids are rocky structure and huge structures. Then meteoroids are also the rocky structure and small structures. When this meteorites draws near to Earth, it will burns up and goes through the atmosphere. When the meteors, then meteoroids comes to atmosphere of Earth, it will burns and forms meteors. Forms meteors. First of all, asteroids smashes and break up and small particles are formed. It is known as meteorites. Then meteorites come to Earth's surface and burns, which leads to formation of meteors. Then here the asteroids are the minor planets. Meteors are just falling stars that just the falling stars. Then the asteroid has an orbital shape or elliptical orbits which orbits around the sun. Then it doesn't have atmosphere. The meteoroids also doesn't have atmosphere. Then what's the difference between meteors and meteorite? The meteorites are on the earth, which are broken parts of asteroids. The meteor are still up in the sky. When the meteorites which burns and forms meteors. Then we have to understand what is comets. What is comets? Comets are dry or dirty snowballs. These are mostly made up of dust, rocks, and ice. These comets, when they orbit closer to the sun, they heat up and release debris of dust and gases. When solid portion of comets consists of mostly of water, ice, and embedded with dust particles, and inactive when far away from the sun, which releases gas from glowing head and which can often be larger than the planet and the debris forms. These can be found in the Kuiper belt. We already discussed what is Kuiper belt, where many comets orbit in the sun in the realm of Pluto. Then we have to understand another one concept. That is exoplanets. Exoplanets. These exoplanets are planets that orbits around other stars, not sun, only other planets. That means in our solar system, our star is sun. Then our planets are orbiting around the sun. The exoplanets are planets which is orbiting another one star outside our solar system. That's known as exoplanet, or otherwise we can call it as exosolar planet. Then this is the conclusion of this topic. Then in another video we will discuss about theories behind Earth formation and another part in the syllabus. Then we can go to some previous year questions, previous year mains question. Then I will explain how to write the answers. The first question is, discuss the difference between terrestrial and Jovian planet. We already discussed about this thing. First thing, you have to write about what is terrestrial planet and Jovian planet. You have to write its difference. We know terrestrial planets are Mercury, Venus, Earth, Mars, which falls to the terrestrial planet category. Then we already discussed about what are the specialities. The Earth rocky-like structure or Earth-like structure. They have a solid surface. They a little no atmosphere and which is closest to Sun or inner planets. The Jovian planets are Jupiter, Saturn, Uranus, and Neptune. These are gaseous or Jovian planet. They are massive. they are made up of gases. Then we have discussed about each planet. You can also write the specialties of these planets too. Then the second most question is, what is the significance of asteroid belt in the solar system? We already discussed about what is asteroid belt. The asteroid belt is located between orbits of Mars and Jupiter that consist of numerous small rocky bodies like asteroids. These asteroids orbits around the sun on its own orbits. Uh, what is the significance of asteroid belt is, we know that the asteroids are huge rocky mass bodies which is orbiting around the sun. Due to the asteroid belts, uh, these orbits helping this asteroid belt helping Earth from rocky asteroid bodies attacks. Then it is a barrier, it makes a barrier for these asteroids comes to Earth atmosphere. Once they fall into Earth atmosphere, the Earth the complete living structure in the Earth will be collapse. Then also it gives some uh, clues for solar formation, or we can study about the past of our planet, or we can study about how a planet look like. These can be found from this kind of asteroid belt. uh, then also it separates the inner terrestrial planet from the outer Jovian planet. These are the asteroid belt. You can elaborate this and explain in a easiest way the right answer for this question. Okay, we can conclude this session. We can see in next video. Thank you all.